Hi viewers, today we are going to see smart polymeric materials in that special type PVDF. Okay, I am Dr. Asrika, Associate Professor, RMK Engineering College, Chennai. Let us get into the topic. PVDF, okay, polyvinylidene fluoride. This act as a piezoelectric material, best piezoelectric material, widely utilized in all applications. How it is synthesized? First, we'll see the synthesis of this PVDF. PVDF is produced by free radical polymerization of monomer vinylidene difluoride. Okay, this process occurs in presence of temperature 10 to 150 degrees Celsius and subjected to a pressure of 10 to 300 atm. So we get polyvinylidene fluoride. You can see the equation here. Uh, Material is processed and fabricated into parts by lot of different methods of casting. One is melt casting, solution casting, spin casting, and film casting. Any of the method can be used to form the material, polymeric material. In this PVDF, we have found that there are different forms of PVDF, right? So here we have alpha phase, beta phase, gamma phase, even people say we have delta phase and epsilon phase. 5 different phases are found in that. These three are the most prominent. Okay, so what is the structure of this phase? See, any smart material, the basic structure decides its property, right? So alpha phase and gamma phase do not show any much piezoelectricity, but the beta phase of the PVDF shows a piezoelectric property. You can see in the figure, right? So what is alpha phase? How it is structured, right? The blue one is fluoride and red one is hydrogen. So this fluorine and hydrogen are responsible for this piezoelectricity. The presence of fluorine and hydrogen atom are responsive for the piezoelectric properties. See how it is arranged in beta phase. All red are one side and all blues are on another side. All hydrogens are one side, all fluorines are on another side. See here, I have represented even in the form of your chemical form where we can see all hydrogen, so gives you positive charge, all fluorine, it gives you negative charge. If you remember in my previous lecture, I showed you piezoelectric property. They exhibit on the surface positive signs and negative signs, right? So positive sign here in PVDF is because of hydrogen and negative sign is due to fluorine. Okay, in gamma phase, you can see the structure, how it is structured. So in this case of structures, they get cancelled out. Blue and red get cancelled out, this plus and minus, and they behave neutrally. But in beta phase, they show this piezoelectricity. See, we have another structure here to for better understanding before applying a pressure, how this positive negative signs are aligned. Okay, when you apply a pressure, so they are mostly aligned, and at the surfaces, you can see one side you have full negative charges, on the other side we have full positive charges. So this develops the piezoelectric property, or we can develop a potential on applying a mechanical stimuli. in nutshell, piezoelectricity is a revolutionary source of green energy. Flexible piezoelectric material are attractive for power harvesting applications. Last slide I showed, right? Car. So underneath the road surface, if we have this piezoelectric material, you can harvest enormous amount of energy and their ability to withstand large amount of strain, converting ambient vibration energy surrounding them into electrical energy. Electrical energy can then be used for power and other devices or stored for later uses. I hope so you understood PVDF and piezoelectric property in detail. Thank you, students. Let us meet in another session on smart materials. Thank you.